Large language models are built on probability. They excel at predicting the next word in a semantic sentence, but that exact probabilistic nature makes them unreliable when asked to perform strict deterministic logic or control local device hardware. Imagine asking a standard cloud model to check the device's battery while simultaneously calculating a complex equation. It easily outputs a conversational summary, but fails the math and returns a battery error because it lacks local hardware permissions. When a system designed strictly for text generation is forced to process binary computational tasks or hardware queries, it guesses. It outputs a response that looks grammatically correct but is functionally wrong. Relying strictly on an isolated cloud-based LLM for device orchestration creates an unreliable user experience where hardware and logic remain disconnected. This bottleneck is exactly what OmniCognitive Agent OS version 2.0 was custom-built to solve. The core architectural thesis is straightforward. To build functional local AI, engineers must decouple the probabilistic conversational engine from the deterministic executing logic. You have to separate the brain from the hands. The framework that bridges this divide is a hybrid-edge Neuro-Symbolic architecture. This system is built to achieve 3 strict operational requirements. First, zero hallucination logic for math. Second, localized semantic memory. And third, absolute data privacy. Mapping the routing path of this architecture provides the technical basis for understanding how these specific components interact on consumer hardware. To see how this works in practice, we will track a single complex user command as it travels step by step through the OmniCognitive routing pipeline. This flowchart tracks the routing path, starting at the very first point of contact on the Android Edge device, before any AI processing actually occurs. The user speaks an additive Sinhala phrase, specifically, Ekasia visi paha, meaning 125. Standard models typically fragment when tokenizing colloquial additive numbers, failing to group the dialect. Here, the universal Sinhala number Lexer intercepts the string, mathematically resolving it into the integer 125. Resolving the spoken phrase into a clean integer prior to hitting the symbolic logic parser ensures the math engine receives a valid number, eliminating downstream syntax crashes. When building AI for specific regional dialects, hard-coded pre-compute lexing is a non-negotiable requirement. With the natural language parsed into raw data, the integer moves deeper into the architecture. This diagram illustrates the agent orchestrator layer. It acts as a strict traffic controller, reading the incoming data and definitively categorizing the user's core intent. If the orchestration layer identifies a strict hardware request, like checking the device's battery level, it employs a rigid routing protocol. These specific hardware commands are shunted directly to native Android APIs for immediate execution, entirely bypassing the large language model. By forcing both mathematical equations and device hardware requests down these isolated deterministic paths, the architecture achieves zero hallucination logic. An intelligent semantic engine is effectively useless if it lacks a deterministic gateway to prevent it from guessing at binary tasks. But what about the queries that pass through the orchestrator and require heavy semantic reasoning? The standard industry approach is to forward these complex queries to paid closed-source APIs like OpenAI. OmniCognitive replaces this external dependency with local infrastructure. This network map visualizes the Hybrid-Edge Backend. It is a fully self-hosted Docker cluster running directly on the user's local home network, utilizing Node.js, a Neo4j database, and Ollama. Within this specific stack, Ollama allows high-parameter conversational models, like Llama 3 or Mistral, to run entirely locally, without requiring external compute. Deploying this localized architecture provides massive reasoning capabilities with zero recurring inference costs. Because the local cloud handles all the processing, sensitive voice data and personal traits never leave the home network or touch the public internet. Replacing external APIs with a localized Docker cluster secures absolute data sovereignty without sacrificing model performance. The final architectural challenge is giving the system the ability to retain context and remember specific facts about the user over time. This data visualization shows the Neo4j graph database, which functions as the system's episodic semantic memory. This dynamic graph syncs directly with native Android shared preferences, allowing the device to instantly recall personal traits in conversational context days later. When the device sits idle, the Agent OS initiates an autonomous web explorer process, operating silently in the background. The system independently reviews its memory for knowledge gaps, utilizes DuckDuckGo APIs to scrape the open web for relevant data, and synthesizes its findings. The underlying model then weaves these newly synthesized facts directly into the semantic graph, completely independent of any direct user prompt. True system autonomy is an architecture that independently structures and expands its own semantic knowledge base. This macro view demonstrates the complete OmniCognitive architectural loop in continuous operation. Notice the strict perimeter of the system. The edge device and the local server continuously handshake, process language, and execute math without ever pinging an external network. To monitor this internal traffic, the system features a public telemetry export function, which continuously logs diagnostic neural telemetry and latency metadata. These logs are routed directly into the Android device's public downloads folder using the Media Store API, guaranteeing total operational visibility for the user. Bridging intelligent semantic preprocessing with an isolated parsing loop creates an auditable agent that never compromises deterministic execution. The hybrid-edge approach demonstrates that engineers can retain high-level semantic intelligence while solving for regional linguistic nuances and data privacy. While standard cloud models rely on purely probabilistic output, this orchestrated system uses that linguistic flexibility as a front end for a deterministic computational core. Standard commercial models often force a choice between deep conversational capability and strict user privacy. This specific Neuro-Symbolic architecture proves that we can achieve both simultaneously, entirely on consumer-grade hardware. The deployment of autonomous systems shifts from centralized data centers to tightly orchestrated networks running directly at the edge.